Hi, let's discuss Form 4 assessment paper. So as a revision for your final year exam. So this one is paper 1, consists of 40 objective questions that will give you 40 marks. Okay, look at number 1. Which of the following SI unit is correct for each physical quantity? So you can see C, luminous intensity, candela. The rest are not SI unit. Okay, so number 1 is C. Number 2, which of following is equivalent to density of 19.3 gram per cm cube for pure gold? So this one is conversion of unit. So you can use this method to solve it. So 19.3 gram cm negative 3 is equals to 19.3 gram divided by cm cube. 1 gram is equals to negative 10 to the power negative 3 kilogram. 1 cm is 10 to the power negative 2 meter. So 1 cm cube equivalent to 10 e to the power negative 6 meter cube. So you substitute here. So gram equals to 10 to the power negative 3 kilogram. Cm cube equals to 10 to the power negative 6 meter cube. And then you just simplify it. So you will get 19.3 times 10 to the power 3 kilogram, k meter negative 3. And then write in standard form 1.93 times 10 to the power 4 kilogram meter negative 3. So this one will give you the answer. Answer will be C. Okay. Okay, number 3. Figure 3.1 shows scale of micrometer through gauge when spindle is fully closed. Figure 3.2 shows scale of micrometer when measurement taken. So 3.1 here, the spindle closed, you cannot see the 0 mark, meaning the 0 mark is inside the thimble. So this one is negative 0 error. So how we read for negative? We just read downward. From 0, 1, 2, 3, 4, 5, meaning 5 division. So the 0 error is negative 0.05 millimeter. Okay, and then you read the second diagram. This one is 5.5, the main scale. And the vernier scale or thimble scale, you read upwards. 10, 11, 12, 13. 13 division means 0.13. So you just total up. You get 5.63. So this is not the actual reading because this micrometer has 0 error. So what you do, you just take the reading of the micrometer, 5.63 minus the 0 error. So here is 5.63 plus 0.05, thus you get 5.68 millimeter. So we get the answer is B. Okay. Okay, number 4. Mass, speed, frequency, and pressure can be classified as. So you can see this is not base quantity, and this is not derived quantity also. The whole physical quantity here is not base, it's not derived. So you look at whether this one is scalar or vector. So from here we can see all no direction. So scalar. So answer is B. And then for number 5, figure shows track of fun run event. All runners start their running at K and finish at N. F2, 6, 10. The question need you to find displacement of the runner. So displacement actually is the shortest distance travel in a specified direction. So meaning you just draw straight line from the initial point to final point. Okay. And then this one, mathematically, we can solve this one. Two, meaning here also 2 kilometer. Here is 6. Total here is 10, meaning here is 8. Okay, so this is a right inner triangle. So use Pythagoras theorem, so you can get Kn. Kn equals to 10. That is square root of 6 squared plus 8 squared. That's equals to 10 kilometer. So that one will be displacement. Okay, so you write down take the answer as C. Okay, number 6, the graph not very clear. OP is straight line. PQ is horizontal line and QR is curve. Which of the following section of the graph is correct? This is ST graph, displacement against time. Gradient equals to velocity. So from here, straight line means constant gradient, thus velocity constant. So B and D is out already. Now we check for velocity at PQ. PQ gradient equals to 0, meaning velocity is 0. Okay, both give 0. Now we look at a QR. QR, the gradient increases. When gradient increases means velocity increases. So velocity increases, the answer is E. Okay, number 7. Figure 7 shows the velocity time of an express train and good train. Both trains are leaving the station at the same time. Okay, at what time they will catch up with the the express train catch up with the good trains, meaning when they reach same distance, because they start from the leaving at the same time. So when they reach at same distance, meaning they will catch up. Okay, now I draw again. This one is not very clear. So this is for express train, this is for the goods train. Okay, now we can check the distance. For this is VT graph, meaning velocity against time graph. So displacement or distance equals to area under the graph. So you can calculate for express train is the area of this triangle. So half times 40 times 20. So we get is 400 meter. And then for the good trains, we have this triangle, this rectangle. So it's 40 times 10. So it's 400 meter. Meaning they will reach the same distance at 40 seconds. Okay, number 6. A car moving with initial velocity 30 start to decelerate at 2 when it is 275 from a traffic light. What is distance of the car from the traffic light when finally stopped? So this is like the car here. This is the traffic light. So distance here is 275. Okay. So initial velocity equals to 30. So let's say the car stopped here. So we need to find this distance. We want to find that distance. So what you do, we find the distance when the car stopped. Velocity equals to 0. Okay. Okay, so you have B equals U plus 80. 30 plus negative 2 because decelerate. Thus we get 2t equals to 30. So we get t is 15 seconds. So you have t. Now use formula, the second formula, s equals to ut plus half at squared. So you substitute the value of u, a and t. So you will get the answer is 225 meter. So meaning it travel past through 225 meter here. So the distance between the car from the traffic light when finally stopped is 275 minus 225. Okay, so we get answer is C. Okay, number 9. A steel ball of mass 20 grams dropped in a vacuum tube. When the magnet is removed, the time fall is recorded, experiment repeated using different mass of ball. Okay, which graph shows correct relationship between the gravitational acceleration g and mass of the object? So you can see the word vacuum here means the object will experience free fall. What is the meaning of free fall? Acceleration equals to gravitational acceleration. So you can see when we drop different masses of the steel ball, it will experience same acceleration, meaning mass does not affect acceleration. So when we plot a graph, we get constant g when m increases. So the graph will be this one, showing that g does not depend on mass. Okay. Okay, number 10, a stone dropped from height 12 meter on the moon's surface. Calculate time taken for the stone to reach the moon's surface. So given g of moon equals to 1/6 g of earth. Okay, so now we can use the formula S equals to ut plus half at squared. So the word drop here means u equals to 0. Okay, so we have S, distance is 12 meter, so 0 plus half A equals to 1/6 times 9.81. And then T equals to, we want to find T actually, T squared. So here we get T squared equals to 2 times 6 times 12 divided by 9.81. So we solve for T. So we get 3.83 seconds. We have the answer is C. Okay, figure 11 shows technique used for tightening a hammer head by knocking the bottom of the handle on a hard surface. Which law? So when you knock the handle to the hard surface, even you already stop, okay, the hammer head is heavier. So hammer head will continue to move due to the concept of inertia. So the law that state about inertia is Newton's first law of motion. Okay, number 12, the function of airbag. This one all is the safety features to reduce impulsive force. Okay, so what we do is find the factor that affect impulsive force. F equals to mv minus u divided by t. This is time of impact. In order to decrease impulsive force, to reduce injury, we can reduce momentum or we can increase time of impact. So the purpose of using airbag is to increase the time of impact. Shows the collision between two cars. Which physical quantity conserved? So all the collision, the momentum will be conserved. This one, the tennis ball, a mass 120 gram, which is initially at rest, being hit by racket. The ball is in contact with racket for 60 milliseconds. After being hit, the ball leaves racket at a speed of 30. What is the average force acting on the tennis ball? We're going to use F m minus u divided by t. So in this case, a tennis ball initially at rest, so meaning u equals to 0. So we have 0.12, the mass convert to kilogram. So you have 30 minus 0 divided by 60 milli. Milli need to convert to second. So you will get the answer. Okay. Okay, you get the answer is 60 Newton. Okay, number 15. So we have Khalid, mass of 70 kilograms, standing on weighing scale or weighing balance in elevator. First, you mark the forces that act. There is a weight downward and also normal reaction force R. Okay, what is weighing balance reading when elevator moving up? Constant velocity. Constant velocity means acceleration equals to 0. So we are going to use the formula F equals to ma. So the net force that act is moving up. So you take R minus mg equals to ma. Okay, R minus mg equals to ma. Okay, So the A here is 0. So we have R minus mg equals to 0. So R equals to mg. So meaning the reading of the weighing balance equals to the actual weight of the person. Okay. So the mass is 70. G is 9.81. So you multiply, you get 687 Newton C. Number 16. The force F due to gravitational acceleration between S and P. What happened? F suddenly disappears. Suddenly there's no more centripetal force. Okay, there's no more force, F. So what happened to the object? You know that when object moving in the circle, it always experience change in the direction of velocity. We call it orbital speed. So when suddenly there's no force that hold it, so P will continue to move in the space in a straight line. Okay. 17. Gravitational field strength of satellite on Earth's surface is G. What is gravitational field strength? Is in orbit of altitude R over 16. Where is the R radius of the Earth? Where R is the radius, tak ada is ni. Where R is the radius, R is the radius. Where R is the radius of the Earth. Okay. This is the satellite at altitude R over 16. So when you want to use the formula G equals to Gm over R2 or R squared, so the R here must be distance between centers of the two objects. So you calculate for the satellite, you will get Gm divided by, this is the distance between centers of the two objects. So you must add radius of the Earth plus altitude. Okay, so you will get this one. So here equals to Gm over 17 over 16 R squared. And then this one equals to Gm over R squared 17 over 16 squared. And this one also equals to Gm over R squared times 16 over 17 squared equals to 0.89 Gm over R squared. So this one actually equals to G. So we have 0.89 G. You can see here. So you need to rearrange the formula until you can get in this term, because you want to relate to the value of G here. Okay, so the gravitational acceleration of the satellite equals to 0.89 G on the surface of the Earth. Okay. Answer is A. Okay, number 18. Okay, given that universal gravitational constant is G, then period of revolution is, so you want to find T, period of revolution. So in circular orbit, we know that gravitational force, that is Gmm over r squared, equals to centripetal force, mv squared over r. So from here we get, we can substitute v equals to 2 pi r over t. Okay, this is speed of the revolution. So one revolution is 2 pi r. Time taken for one complete revolution is period. So we have speed, okay, equals to 2 pi r divided by t. So you just substitute here. Okay, some of the, here you can simplify. Okay, so we get what? Gm equals to 2 pi r over t squared. Okay, thus we can get t equals to 2 pi r cubed over mg. You can try yourself, this one. So the answer will be D. Number 19. Escape velocity of the Earth 11.2 km per second. Saturn has mass 95 times of Earth's mass and radius 9 times of Earth's radius. What is the escape velocity from the surface? So this one we use the formula escape velocity, v equals to 2 gm over r. And this one equals to 11.2 kilometer per second. So for Saturn, we can calculate as v for Saturn equals to square root of 2g, the mass is 95 times. So you just put 95 m. Capital M is mass of the Earth. And the r equals to 9r of radius of the Earth. And then we can rearrange again, so we get square root of 95 over 9 square root of 2 gm over r. So remember this one, 2 gm over r is equals to escape velocity of the Earth. So we just substitute here, so you will get 95 over 9 and then times 11.2. Okay, so we get the answer. Okay, so the answer is 36.4 kilometer second negative 1. Okay, number 20, mercury thermometer that has not been calibrated. Length of the mercury thread of 5 cm and 65 cm from 0 and 100 respectively. So when thermometer placed in hot liquid, length of mercury thread is 40. What is the temperature of the hot liquid? So you want to find the temperature is equals to L theta over L100 times 100 degrees Celsius. L theta is 40. L theta is 40 minus 5. (100 minus 5 times 100 degrees Celsius). So I think this one is already wrong. This one, the 40 cm must start from here, and the 65 must start from here, and this one is 5 cm. So that's why the length here we call it L theta for this one. and this one will be L100. Okay, so you get the answer. Okay, 35 over 95, sorry, 65 here, 65 minus 560, yeah, times 100, so you get 58.3 degrees Celsius. Number 21. Diagram shows body temperature of buoy being measured using digital thermometer. Thermal equilibrium between buoy and thermometer achieved when? Okay, you must remember the definition of thermal equilibrium. The rate of heat transfer between buoy and thermometer are equal, or the temperature shown on the thermometer scale is equals to the temperature of the buoy. Okay, so you have D, the answer. So I stop here. We continue the next question until number 40.